Hello everyone, this is Professor Ratajczyk, and in this video I want to walk through the Butler trucking example of how to use simple linear regression for the purpose of better understanding how to put together a formula and think about your results. Okay. So before we begin, there's a couple of things in my file that you will not find in your file. For purposes of demonstration purposes, I will reveal them very shortly. So we have a typical situation here where your boss comes to you and says, hey, I think there's a relationship between miles and time on the road. And I need to see a model that can predict how long it would take to drive 30 miles, because we're thinking about adding in travel or customers that are a little bit closer to us than usual, or we're thinking about picking up some new clients just in general, and we want to have a model that gives us an idea of how long it'll take to do the job. And then we can evaluate our schedule, our supply chain, our logistics to see if we need to hire new drivers or more drivers, or just have them change routes. That'll be more efficient and effective. So that's what we need you to do here. So go ahead, do it. And you'll say, yes, sir, Colonel, sir. So what I like to do with simple regression for the purposes of what we're doing today is create a chart, a scattered chart. So I go up to insert, I go over to scatter, and I like to use a blank slate. I know you can easily just grab some columns and try to make a chart, but sometimes Excel makes mistakes and I like to have more control. So I'm going to go over here to add, and it's going to be your trucking assignments. Good. Trucking assignments. The X variable is going to be your miles, and your predictor variable, which is Y, is your dependent variable, is going to be time. Now it's key here that I put in the names there. What I want you to see, what happens here is the formula is going to pick up on that, and we'll see how it goes. Okay, so by doing that, we've actually introduced a mistake. So it's very important that you don't grab the variable names. There we go. Now that should look more like your slides. Okay, so what I did there was I noticed that this was off, so I just dragged this down a little bit. Okay. I also noticed that our title is missing as well, the one that we put together there, but don't worry about that. That we'll figure this stuff out as we go. Now, one thing that I want to show you though is, see all this blank spaces there, really causing havoc in our model. For it to change the color scheme here. There we go, a little bit better. So I'm just data inking this up a little bit. Butler trucking assignments. Okay, and this is going to be our miles. Okay, and this over here is hours. Okay, now you can see here I can blow this up a little bit further, but I've got all this white blank space here, right? Empty space. Tuft, so Edward Tuft from the data inc from data visualization would say that's a big no-no. So we're going to right click on each of our axes, format axes. Oops, sorry, format the axes, not the title. And we're going to go over here and we're going to put in a 40 because it looks like our first numbers are right at about the 40. Okay, so that breaks that apart. Now let's do the same thing over here with the hours. So we'll right click on the axis for hours. And it looks like we've got 4 hours as a minimum. So let's just do a 3 there. There we go. That looks pretty good. Okay. Again, this is just for visual purposes. It has no impact on your regression model because the dots are where they need to be. So now I want you to right click, add trend line, and then by default it's linear. And then what I want you to do is go down, display the equation on the chart, and display the R-squared value on the chart. Okay, so this is a text box that was generated, and if your eyes need help, you can make sure the text box is selected, and then go over here and put in, I don't know, like 20. There we go. That's a nice number. Okay, so now we've got our formula easy to see. You can even put it in red if you wish, or yellow, whatever makes sense to you. Make sure it's not, again, sherbet ice cream rainbow or My Little Pony color schemes, things like that. And actually, I like yellow in this instance, not just because it's got a black background or gray background, but because this box over here is yellow, and this usually suggests that the user has to do something in that box. And that's exactly what we're going to do next. We're going to put in our formula. Y equals 0.0678 times 30. And where did I get the 30 from? Well, my boss told me to put 30 in. Plus the intercept of 1.22739. And that gives me a 3.3. Okay. So now you have to ask yourself, this is where you get paid the big bucks. It's not in punching in these numbers. Anybody can do this with a 5-minute video recording, right? You just did it if you were following along. Anybody can do that. Okay. What you have to do is you have to analyze the result. In other words, first thing you should say is, does this make sense? Does it make sense that there's a relationship between miles and time, evidenced by this 3.3? So what this is saying is, if I want to drive 30 miles, it'll take me 3.3, which is really 3 hours and 20 minutes. It will take me that much time to drive 30 miles and do this job. You have to ask yourself, where on earth would it take you 3 hours to drive 30 miles? Seriously, think about it. Where? Because that's going to help you. Where would it take 30 miles? Well, jungle, tundra, mountains, bad roads. Remember, these are 30 miles. Who's calculating the miles? Is it a linear path, or is it right angles like streets and blocks, city blocks? Are there any diagonal streets that cut right through, etc.? So that's where we start talking about multi-regression. And I'm going to introduce you to these variables. So we have truck routes, accidents, and street signs. So this model sucks. I mean, without a doubt. I mean, the R squared is healthy. We typically want the R squared above 70%. So it's right about there. But there's something going on here that you need to inspect further. It should not take 3 hours to travel 30 miles. There's something going on here. Either the data is bad, or there's several variables at play here that we did not put into our model. So here's the other place I want you to look. 3 reasons. 1, the sample size is too small. There's not enough variety in the data. There's not enough variety in miles and time. The lowest travel time in your model is 50, and you're asking for 30. I like to see your model built off of reasonable behavior. Okay, mark that down. Model built off of reasonable behavior. What that means is you should have some observations that reflect reality of what you're trying to solve, right? I mean, why stop at 30? Why don't we put like 30 million miles, right? Why not? Well, there's a problem with that because we never experienced that. That's not our business to travel 30 million miles. We haven't gotten any history on traveling 30 miles before. Those 30 miles might not have any truck routes. That 30 miles might be accident prone, lots of accidents in that area. We don't know. So it's likely to blame the statistical model. Okay. So number 3, as I said, we don't know what the entire route contains. So even these routes over here, how many truck routes were there? How many accidents were there? How many street lights are there? Are there none? We don't know those things. So that's where you get paid the big bucks to realize, regression might be good for your business. We'll get into that later. But your regression model might look good, but it really isn't good for business purposes. Okay. So that's where you got to use your stats hat, but then you've got to come back down to earth and realize you're a business person making a decision, and you have business data that represents people's behaviors, You have rules such as road signs. You have laws such as stoplights require you to stop for a certain amount of time. You've got regulations that require trucks that have certain amount of weight on them take different roads than normal vehicles. So you got to put it in those terms as well. So bring it back down to earth and not always rely on the numbers to tell you what to do. That's a very important lesson here. So that's the demonstration and the wrap up of the lecture here. A couple of things I want you to look at in the lecture is Achman's razor, which basically says, make the model as simple as possible. Just because you have 60 million rows of data and just because you have 5,000 variables doesn't mean you use them all. Okay, so look up, think about that. Look in the PowerPoint slide. Make the simplest model possible without sacrificing a lot of accuracy, is what that's saying. Thanks.